Right. And there'll be videos of both of these up. I videotaped it yesterday. And once this one's done, I'll put this one up as well. Alright, so 1 plus sine negative y. 1 plus sine of y equals cosine squared y. What's our first move? For the binomial on the left. What do we see? What do we think of when we see sine negative y? What are we going to do with that negative? That's if we have pi over 2. I would agree with you with pi over 2 minus x. But these are the odd evens. So when I have a negative on the x, I pull it out. So this, instead of 1 plus sine y, becomes 1 minus sine y. The exception to that, of course, is what? Cosine and secant. Instead of negative, that goes to positive. Now, they're conjugates of each other, so that becomes 1 minus sine squared y. And 1 minus sine squared y is equivalent to cosine squared y. All good? So when you see the negative of the variable inside, unless it's cosine and secant, you pull the negative out. If it's cosine and secant, just drop the negative altogether. All right. Cosine over 1 minus sine x equals secant x plus tangent x. One route is the conjugate. All right. One route is the conjugate. Conjugate of 1 minus sine x is 1 plus sine x. When I do that, I'm going to have cosine x over 1 plus sine x. Again, do not distribute. Leave it. Over 1 minus sine squared x. As soon as we see 1 minus sine squared x, that's going to become cosine squared x. This is why I don't distribute. Because more often than not, we're going to be able to cancel without distributing. Everybody good so far? So the cosine over cosine squared is going to leave me with cosine x in the denominator over 1 plus sine x. Is my denominator now monomial? Yes, so can I break it down into the two parts? Yes, so it becomes 1 over cosine x plus sine x over cosine x. By reciprocal or inverse identities, 1 over cosine x is secant x. Sine over cosine is tangent. Boom shakalaka. I have the exact same thing. All right. For number 3, now I have the pi over 2 minus x, which is cofunctions. Sine does not have the co, so I'm going to add it. So sine squared becomes cosine squared. Addition's commutative, so that's just 1, and 1 is equal to 1. Underneath, now I have the co with the pi over 2, so I'm going to drop it. If I drop co from cotangent, what do I got? If I drop the co from cotangent, what do I got? Tangent. And then I'm going to isolate the secant squared y, since that's isolated in Pythagorean identities. Secant squared y equals 1 plus tangent squared y. And secant squared y equals secant squared y. All right. We talked a little bit about this the other day, but now I got nested parentheses, man. You could, because secant squared minus tangent squared is equivalent to 1. Yeah, you could. But you'd still be correct. That's just so that you see it's a Pythagorean identity. So in other words, if you went, if you went right from here to 1, that's fine. Because it's equivalent to 1. I'm okay with it. Alright, again, I got a co and I got a pi over 2. So this becomes sine x times secant x. This becomes sine x times 1 over cosine x. And tangent x is sine x over cosine x. And then you can have sine x over cosine x equals sine x over cosine x. Now, 6 is a little bit of a trickster because 6 has 4 terms. And what should you think of when you have 4 terms? Grouping. So I start with that. I pull out the 2 secant squared x. And I got 1 minus sine squared x. Everybody good with that? Okay, the problem is if I come down here and I pull out a negative 1, I got sine squared x plus cosine squared x. So my problem is usually if you do grouping correctly, the 2 parentheses are what? Exactly the same. They're not. Doesn't mean we're wrong, we just got to take a different approach. 1 minus sine squared is equivalent to what? What is 1 minus sine squared by Pythagorean identity is equivalent to? Cosine squared. So that 2 secant squared x, cosine squared x. And sine squared plus cosine squared is equivalent to 1. Are secant squared and cosine squared inverses of each other? So what are they going to do? Cancel out, leaving you just with the number what? And 1 is equal to 1. So that's a little bit of a trickster. But if you see 4 terms, definitely start with grouping.
Can you do it without grouping? Or is that what? Because I didn't group, but I still got that.
What'd you do?
I'm not quite sure. Look at it.
I'll try not to hurt myself.
Yeah, I just like look out early.
See, I don't know where you're working. It's not really, it's like you just pulled stuff. So,
I think it says, because I saw that.
you put the sine squared over cosine squared, which is fine. We'll look at it. Let me get through this, we'll look at it. There's some jumps that I don't quite. Alright! Cosecant x times cosecant x minus sine x. Wow, this one's fun. Plus sine x minus cosine x over sine x plus cotangent x. Alright, so here's what I'm going to do. I'm going to go 1 over sine x. Go 1 over sine x minus sine x over 1 plus sine x over sine x plus cosine x, nope, minus, kidding, over sine x plus cotangent x. In other words, write everything in terms of what? Sine and cosine. Alright? Sine over sine is what? 1. Make sense? Cosine over sine is cotangent. What is that going to enable me to do with the negative cotangent x and the plus cotangent x? Cancel out. Good so far? Now I'm going to go to work on this. 1 over sine squared x. 1 over sine squared x. Minus 1. Everybody good with that part? Because the sine x and the 1 over sine x are going to cancel out. Now what are the negative 1 and the plus 1 going to do to each other? Cancel out. So now I got 1 over sine squared x versus cosecant squared x. And you can go either way with it. You can either rewrite cosecant squared as 1 over sine squared if you want to write everything. Or if you know 1 over sine squared is cosecant squared, either way it's going to be completely fine. Okay? Cotangent and tangent are inverses of each other. So what are they going to do? Cancel out. Give you 1 over cosine x. What is 1 over cosine x equivalent to? Secant x. Boom, we're done. God bless. God bless. Secant x is 1 over cosine x. Cotangent x is cosine x over sine x. What do the cosine x's do to each other? Cancel out, leaving you with 1 over sine x. And cosecant x is also 1 over sine x. So you can write them both like that should you choose. Alright? Number 10, I have different denominators. So I got to find a common denominator. So 1 plus sine x gets multiplied by 1 plus sine x. Cosine x gets multiplied by cosine x. And I'm going to leave my common denominator without distributing. So cosine x times 1 plus sine x. I'm then going to have 1 plus 2 sine x plus sine squared x plus cosine squared x. And my numerator. If you want to... what's up, bro?
This is for number 9. How come it doesn't end up as cosecant x equals cosecant x?
Because you could have done it that way as well. So I did that in the other one. So in other words, that's what I did in 9 or 8. So in number 9, I just rewrote the cosecant as 1 over sine. To show people you can do it either way. So if you wanted to, so 1 over sine x is cosecant, you could do it either way. I just want to show everybody how you can end up both ways and still be correct. Good? So you can write it that way as well. Alright. Sine squared plus cosine squared is 1. 1 plus 1 is 2. So I have 2 plus 2 sine x. So I'm just focusing on my numerator. Do they both have 2's in them? You bet you. So I got 2 over 1 plus sine x. Now I bring back my denominator. Cosine x over 1 plus sine x. What do the 1 plus sine x's do to each other? Cancel out, giving you a 2 over cosine x, which is 2 secant x. Good? Alright, 11, we've already discussed to do the more complicated one first. In this case, the one on the left would be more complicated because you have a binomial denominator. So I'm going to multiply by the conjugate once again. Sine x times 1 plus cosine x times 1 minus cosine x times 1 plus cosine x. Again, I'm not going to distribute on the top. So I'm going to leave that as sine x over 1 plus cosine x. And on the bottom, I'm going to have 1 minus cosine squared x. One minus cosine squared x by Pythagorean identities is sine squared x. The sine x over sine squared gives you 1 over sine x times 1 plus cosine x. And when we multiply by 1, we just stay exactly the same. And after 6 years of teaching this, I finally figured the easiest way to do it. And then the bottom one's going to be similar. Cotangent x, cosecant x plus 1, cosecant x minus 1, cosecant x plus 1. Equals cotangent x, cosecant x plus 1, They're conjugates of each other, so I'm going to have cosecant squared x minus 1. By Pythagorean identities, cosecant squared x minus 1 is cotangent squared x. And when I cancel out one of my cotangents, I'm going to have cosecant x plus 1 over cotangent x, which is the same thing as on the right. Good.